Hi, I'm Bob Claymore with the Ohio Technology and Engineering Educators Association, and this is our monthly OTEEA webinar. And this month, every other month, is on elementary, K through pre-K through 6. And we're going to get into this today. It's on electronic sentences, which has to do with programming and physical computing, which we'll talk about that, and also language development. So let's take a look and see what's happening here. Let me go ahead and share my screen and I'll run you through a PowerPoint and talk to you about a couple things here. So here we go. Let's see. Can you see that? Did I get it up? Probably
No,
didn't.
it's just you and I on the screen.
Okay, then let me go back to my thing and we'll go to share.
There it is, title page
Yeah,
and
so
border.
join. Oh, share. Okay, yeah, okay. Then hang on a minute. Mr. Professional here. Let's get this up. Share. I'm going to stop the share for a minute and I'll go back and share it again. There we go. Did that come in?
It's not full size.
No, I've got to run it. How's that?
Bingo.
Okay, so we'll run it all the way back to the top. No. There we go. Okay, electronic sentences. So what they are tiles that children use. This is for pre-K or kindergarten through, I'd say, third or fourth grade. That can then, they can use these tiles to write sentences that will actually control devices. So it combines design and control, problem solving, coding, and physical computing, and language development as well. So as we just talked about, it's designing and problem solving English language skills through coding and challenging activities that reflect the real world. So we've presented this idea has been developing. We've presented to teachers. We've done some work with some kids with it, and we'll show you some examples of how this might work. Okay, they build upon technology education ideas for real world design and problem solving. It works with coding and control, practical meaning context, provides a foundation for progression in coding and development or design and problem solving. And I think it does a good job with connecting physical computing. In other words, using computers to actually do something in the physical world, interact with the physical world. Okay, so we're continuing to build on this, and the idea is to get feedback from teachers and educators and so forth, and then bring in support from language arts people to help us develop that and strengthen that as well. Okay, so here are the tiles, and there's individual tiles. You can see they connect together by arrows, kind of like jigsaw puzzles. Each tile has a radio frequency identification tag embedded in the graphic, and then the scanner below reads what that code is and sends that as a sentence, a control statement, if you will, to a smart block. And the smart block is the one that actually controls the different devices. So for example, a child could decide if it's too dry, they need to turn on a pump, or if they're near a magnet, then a motor could run. So we'll take a look and see how this works in a minute. Okay, the tiles are in different categories. There's input tiles, as you see in the blue on the left, hot and cold, wet and dry, light and dark. There's process controls, if and then statements, count, do not count, do for so many seconds, do forever. And there's outputs, so they could end up with a smile, they could make a sound, turn on a motor, turn on a lamp, a heater, a fan, pump, so forth. And then you also have starting and stopping tiles. If it is always the beginning of the sentence, and then a period always ends a sentence, so that the scanner knows that that's a complete sentence then. Okay, here's just a breakdown of some of the different tiles that are in there. The input tiles there you can see sorry. Yeah, the input tiles are there in blue, near a magnet if it's dark, if it's light, and so forth. The yellow tiles are the process tiles, forever, then, or for so many seconds. And then the output tiles are in the red. And then you also have the period at the end, and if it is, which is the starting tile in the beginning. So the kids would then read a problem, figure out how to solve it, make a sentence using the tiles, scan it, and then the smart block would actually run the process that they need to do to solve that problem. So here's an example of how it would work. If it is dark, wet, light, whatever, then do this, turn on a lamp, turn on a fan, turn on a pump or something like that, and then stop. We're going to see some examples of kids actually making these sentences and then running the smart block. We also have activities with them. So there's activity cards that give kids problems to solve, and they range from most familiar, is she at home, which would be a very familiar environment for the kids, all the way to in the world, which would be a little bit less familiar to them. Also, each home, each little set runs from limited choices for simple ideas that kids could start with to more complex, open-ended solutions to problems. So there's not only the different environments, but also each environment or each set of activities goes from simple to more complex as well. Okay, here's some examples of those. For example, this is at home. This would be a very simple one, plant care 1. Grandpa sometimes forgets to water Grandma's plants. He does not want her plants to be hurt from a lack of water. What to do? Well, we design a system that will turn on a light to alert Grandpa that the plants need to be watered. So the kids would read this, decide what tiles they need to do, how would they set up the sentence, what sensors do they need to run this, input and output devices do they need to run this. Then they would set that up, write the sentence, scan it, and then to see if the smart block would actually solve the problem. Okay, so to solve, for example, here's a merry-go-round in the background. So if they want to run the merry-go-round, they would write a sentence, for example, a parent has created a carousel ride for the school feet and needs a control system to operate the ride. Design a system that will operate a motor when the button is pressed and switch off when the button is released. So this would be an example. If it is, which always starts every sentence, pressed, then turn on a motor for so many seconds and then stop. And you can see the little carousel in the back there. And this other little piece there, even though it talks about being hot and turning the fan on, not turning a motor on, but that's the smart block. And so the scanner is going to scan this sentence, and then the smart block will get that information and then be able to operate the appropriate sensors, the appropriate input-output devices. And so the motor runs a carousel. Okay, here's an example of just how it works. So let's get into this one. Here you see the sentence. If it's pressed, then turn the motor on for so many seconds. And here's a scanner. The scanner reads this, starting with the if it is, reads each piece. There's coding in each tile. And you can see it building on the smart block. And notice that the smart block has devices, a press button, and also a motor hooked to this merry-go-round. And so if it's read correctly, when you hit the smart block button, and then you can press the go button, and then it actually runs the carousel. So in this way, the kids can write control sentences and see something actually happening, some physical thing actually happen as a result of their sentence. Okay, here's another in the same idea. This material in the upper right-hand corner are Teacher Geek materials, which work really well with this. It's not exclusive to this. This will run with a lot of things, but Teacher Geek works really well with this. It's very simple, very easy to put together, and has a multitude of uses. So it's a nice fit for this kind of activity. Okay. So here's a plant watering system. Grandpa, remember, forgets to water the plant and needs to wait to remind him, so he turned on a light to make sure that the plant gets water. So let's run this one. So again, the student runs the sentence. If it's dry, then turn on the pump. And so here, the pump would run and start watering the plant. Okay. Now, these are some prototypes that they developed. We're not going to spend a lot of time on this, but you can see that they spent a lot of time thinking about how to best create this to make it very easy for the students and yet very effective in getting done what they want the program to do. So it's gone through a lot of iterations. This is a smart block concept. This is the one where you hook in the input outputs, and this also reads the scanner to then actually run the device or whatever that the kids have decided to create with their sentences. Okay. This is what the more modern one looks like. This is kind of the current piece. You can see the different devices in the back. There's a push button, there's a fan, there's a light, there's a pump. The smart blocks in the foreground, the scanner is there, and you can see how they plug into the different, there's different inputs in the electronic scanner that you can hook these devices to, and then once you scan in your sentence, if it's written correctly, then the different pieces will work. Okay, you get a better look of how that's set up there. For example, if it's hot, then turn the fan on. So if somebody wrote a sentence, they scanned it in, it shows up on the smart block, and then the appropriate devices are hooked in, and it should work. Okay, this is about physical computing. Physical computing is a popular term now. It means when you have a computer to interact with the world in a physical way. For example, it's running different switches, it's running different control systems. So Tech Ed has been engaged with this physical computing piece for years, and this is a way to get young people involved with this and understand what's going on. So plan developments include strengthening links to engineering by design, which is the ITEA, International Technology and Engineering Educators curriculum. So they've got plans to integrate with that system, which would be great. Using practical control systems and transforming them into conditional sentences. Has a language arts component, which we think is a really strong feature of this development, and also working with language development specialists to help make these products even better. Okay, and then we can expect feedback. These are the kind of feedback things we would get from our participants, the people that experiment with these. And here's some of our members, the US team, and also we have people in the UK that are working on this as well. And Rod Todd is the project coordinator. So he's been working on this for a number of years, and it's starting to come together, and we're excited about that. And that's my slideshow. Do you have any questions on anything so far, Dick?
Yeah, but I was going to ask, like, can like new words be created in blocks, or new wording for sentences?
They've talked about having a blank piece like that. It would be, I'm not sure how they would set that up because it has to be programmable into the computer, into the smart block. But I know they're going to develop more pieces as time goes on, but they want to start out fairly simply so that the kids weren't overwhelmed with choices. You know, they want to kind of limit it somewhat so that the kids would be successful and really understand what's going on there. Yeah.
Yeah, about how many different kinds of scenarios have they created for
well, the
steps?
Yeah, the activities they've probably got 20, 25 activities that they can do, ranging from very simple to more complex. And the sensors and so forth, they probably got about 10 input-output devices, buttons and motors and fans and things like this that they've got into that.
Yeah, nice way to carry it on too would be if someone scans some of the kids' story trade books.
Yeah,
and there might be some stories that have situations where these devices,
right,
would fit in.
Yeah, or at least they could read the book and figure out a problem that they could solve with the scan with the tiles as they are. Like a fairy tale would be perfect for this. Let me go ahead and show you a couple of real short videos of kids actually doing using the block. So let me get to that. Okay, we'll start with this young lady here. This is Eileen. So here's Eileen, and she's going to solve a problem.
Hi, Eileen.
Hi.
So, you know, sometimes when people come to our house and they knock on the door, we don't hear it?
Yes.
What would help us to know that people are at the door?
A doorbell.
A doorbell. So how would you go about making us a doorbell with the stuff that you have there in front of you?
So first I'll start with the green light and then end with the red light. I'm gonna put press.
So what does that mean? What does press mean?
Press means like you press a button.
Oh, good, okay.
And I'm gonna put it right here. So then I'm gonna put then. So because you need to space it out. And then I'm gonna put make a sound because doorbells make a sound. I'm going to connect it. So now what I'm going to do is I'm going to put pushed and sound in an order. So now I'm gonna turn this on. Just have to wait. Okay. So what I'm going to do is if it is pressed, then make a sound. So now what I'm going to do is I'm going to push the button.
What do you have to do before you push the
I
button?
have to hit go.
Right, now push the button. Hey, all right. Try it again. One more time. All right, very good.
Okay, so that gives you an idea. Now you notice that they've actually combined the scanner and the smart block into one unit, which I think is a really smart idea. And you notice she had to start the sentence with if it is, and then she starts with that, and then she can build out from there and go. And you notice the different colors. The first one's an input-output device, and then she has the, then, which is the process, and then the final thing that's going to happen in the end, and she has to end it with a period. So they have to write a complete sentence. It's language development. It's based on regular children's language, English language. And it also involves coding because they're writing a sentence that's actually a form of a code. The scanner breaks that down into coding that that they can then use to run those sensors. I think it's pretty cool. Okay, let's go ahead and switch off and show you one more of those. So this one's another young man that was working on it. Here's Ben. Maybe. Hello, Ben. Where are we there, buddy? Let's go here. Oh, okay. I've got to get rid of Eileen. There's Ben. He's hiding in the background. So let's go, Ben. Let's see what you got.
Hey, Ben. You know, our new dog, Willow, she likes to escape. So sometimes we don't even know she gets out, but she's already gotten through the door. So how could we do something to let us know that Willow passed through the door? What could we do?
Well, let's say if Willow has a magnet on her collar and we put like some type of magnetic thing on the door, if she goes near that door or she gets out, it will make a sound to alert us that she got out or like she's near the door.
Is that because she would pass that magnet sensor on the door?
Yeah.
Right. Okay, so what would the sentence look like in order to make that happen?
So first we do, if Willow is near a magnet or if it is near a magnet, then it would make a sound. This means go because it's highlighting the green. This means red, or like stop. So what we're going to do is we're going to plug this into a scanner. So we're going to put magnet in because that's the first one in the sentence. Then we're going to put in sound. And then what we're going to do is we're going to scan it, the sentence. So if it is near a magnet, then make a sound. Make sure to get the end because it has a little period and it won't work without that period. So what we're going to do is we're going to hit go. We're going to put this magnet on top and it makes a ringing noise.
Good work.
Okay, there you go. Now these kids were, the dad was involved in the project, so he understood that. Obviously they were coached a little bit, but I really do think they came up with their own solution to the problem. Given the materials that they had to work with, I think they came up with an idea how to solve the problem themselves. So that was kind of neat, and it does, obviously does work for young children. Now, they have to be taught about how to write the sentence correctly, how to scan it correctly, how to hook things in. But I think after that it becomes rather intuitive, and so they can actually program it, use this sentence writing as language development, and then you actually have the sentence do something. It's not just a sentence where they read it and here's the solution. They can actually see the solution that they've written come to life. And I think that's a really strong feature of this particular program. It's not quite developed. It's not ready for market yet. They're hoping to get this tested this summer with a group of teachers, make final adjustments, and then hopefully get it out late this year or maybe early next year. But it's really close. It's really close to production. Any questions, Dick?
Yeah, is their technique pretty unique in terms of the approach of the conceptual teaching for coding?
Yeah, I don't know of any other thing that works like this. I haven't seen anything else on the market that is similar to this. So there's certainly some things that where kids can program stuff and get it to run a robot or something like that. But as far as writing a sentence, I don't know if anybody else has a program that's like that with actual sentence and language development.
Are they going to evolve into sentences that are longer, kind of more compound statements or something?
They certainly could do that. Of course, we're starting out. We want these young kids like this to be able to write simple sentences so that they really understand the concept and don't get overwhelmed with it, because it's really new to them to think this way. The kids are not used to thinking unless they've had some kind of coding or programming skills to think like that in terms of if then do this. So to start out simply makes it easy, and then I think that eventually, yes, they could put in more complex sentences to make that go that way too.
Then were the pieces that were shown on the bench, that's the variety that comes with the set, or are there
Right.
Or there more? Yeah.
That's what they have at this time, and I don't know what's in the in the works, but I know that's what they have at this time. So you can do quite a bit with what's there. I mean, you can run motors and pumps and lights and all kind of things. So it's pretty open ended. It's not you have to do this. You can think of different solutions to different problems and solve them in different ways. So it's really and you don't. There's as long as you can write a good complete sentence, you can make something happen. I think it's pretty neat.
Yeah, I see where if you had multiple sets, you could have a number of kids working together. They decide
Right.
what are the major action steps they want to take, and then they could each write an action step and then string them together or play them together.
Yeah, and teachers could use the board, the smart board or whatever, to set those up and show them how it works. That the class would set up as a problem together, and then break it out into groups that way and work it off that way too. So, and I think it's got a tremendous lot of possibilities, and I'm excited about it.
Yeah, is there a need for other kinds of support equipment, or you mentioned like the smart board? Do they have it?
No, you don't need a smart board at all. What you see there is all you have to have. So, I mean, you could have a thing like a carousel to run or a pump to pump. You would need some of that, but as far as anything else that you would need, or the teacher geek or whatever to build a contraption that you want to manipulate, but you really don't need a lot of stuff. It's pretty well self-contained. So, yeah, and I think the teachers are going to be comfortable with it that haven't had a lot of coding and programming or design thinking, because it's based on language and they understand language, and that's 80% of what those younger grades teach. They're really strong on that, and so we've gotten some feedback from language teachers about this, and they're on board with this. They think that this is going to be helpful, not only to learn programming but also how to write a good sentence.
Yeah, the steps would fit in nicely because there's a number of things where they just kids to be doing very clear, accurate statements and follow directions.
Exactly.
So you could face a number of these devices and strategies together.
Right.
Build the skills for accuracy and communication.
Right, and it's that technical. It's a form of technical writing, if you will, and that's a skill that sometimes gets overlooked in the early grades. So that's cool. All right.
Very nice. Thank you.
Well, thank you. All right. If you don't have any more questions, I'm going to go ahead and stop the recording, and we can talk for a bit.